I was hoping that I didn't have to make this lecture, but I'm sure many students would have had trouble during the exam if they were to go over these types of problems. So what is it? Well, to preface here is that we are dealing with the fundamental theorem of calculus again. That's right. We have still the original rule here, right, of the fundamental theorem of calculus, known as what the definition of a definite integral looks like. So in our case, with the definite integral going from a to b for some function f of x of dx, that would mean it results in the difference between the two limits of the integration function, right? The one that was outputted from the integral of f of b minus f of a.
Wait.
You might think, this is exactly what we dealt with before. Indeed, it is. But we have one serious issue. We have certain problems that will arise on the AP exam, in which I'm sure if we did not talk about it explicitly, a lot of students would have no idea what to do next. And that will look just like this.
Whoa, my goodness!
We have a derivative outside of an integral. What is all of that? Is that even possible? Like, seriously, we have a derivative and then an integral and then a variable as a limit of the integral? Oh, calculus is too hard. We might as well just give up. Settle down. We're not quite out of here just yet. All right? This is simply a continuation of the full understanding of what the fundamental theorem of calculus really is. How is that in any way in reference to what we have just right there on top? But like we said before, this is why we need a full understanding of the fundamental theorem as to why they will ask exactly these types of problems on the AP exam. So let's go over this one step at a time based off of what we just established. We can then understand first that this integral does have a solution to it, although we don't necessarily need to know exactly what that is. Again, the fundamental theorem will guarantee that there will be, in our case, if we just leave the derivative alone for now, and we'll come back to that one at a later time, there will be some sort of result from this definite integral that will give us a function. We can call that capital F, but now we do have limits defined. We have capital F of x this time as a result of the integration, but now we must also subtract it from the capital F of -1. Again, it is that resulting integral function in which we haven't found yet, but we do understand that some sort of function will arise from this integration. No doubt about it. Okay, now let's think about this. We do have a function f of x, so that is going to be left in a function form, but the f of -1, well, would you look at that? If you plug in any sort of value into a function, you must get, usually in this case, a numerical answer. Of course, you just plug in a -1 to whichever function comes out of the integral. Again, we don't need to know exactly what it is, but because of that, this will make our lives of deriving it much easier. Again, derivative rules, we can just use addition rule. There's no need to worry about it. We just have to go one at a time for the derivatives of either. So let's take that to the next logical step here. We will then have the capital F derivative of x subtracted by the capital F derivative of -1. Okay? And just like we have said previously, f of -1 already is a numerical value, so the derivative of f of -1 will just give us 0, because it's just a number and any derivative with respect to x will give it back to 0.
Isn't it wonderful?
Not really.
Not really? Don't worry about it. We still have this whole issue to deal with. We have the resulting function from the integral, but we must then take its derivative. When have we ever thought about taking the derivative of the result of an integral? Wow, that really brings back memories, doesn't it? Because remember, from all of our times that I have yelled at to you for the definite integral series, backwards now to the indefinite integral series, the first series on this YouTube channel, is that of course, no matter which answer that results from an integral, if we then took that derivative of it, every time, 100 out of 100 times, whatever proposed answer that comes out of an integral, its derivative must match, right? It must match exactly down to the letter of the integral. Oh yes, after all of these times of yelling about taking the derivative of our proposed answers of our integrals, it finally comes full circle. That answer, whatever it might come out to, we know that its derivative must exactly equal to what was inside of the integral to begin with, as if we were checking our work once again. Now, one thing to note, of course, is that we are dealing with the variable of x now that was plugged in, and not the variable of t, or whichever one was inside of the integral at the start. So we wouldn't even need to show any sort of work, because this is a bona fide fact for us, because every time we take any sort of integral, if we take the derivative of that proposed answer, it will match 100% to that integral, otherwise it wasn't a good answer. So because of that, we can then simply result all of this as the now square root of 1 plus the sine squared of x this time as a result. And there you have it. Everything has already been taken care of. No need for chain rule, no need for anything else other than the fact that you understood that you just plugged this right into where the t was, because that was the limit. And of course, any derivative from a resulting integral must match what was in the integral at the start of the problem. Oh yes, now that was pretty good. Some might even say, there you go. This was indeed the best way of showing how people really understand what the fundamental theorem of calculus is. And the test proctors on the AP exam in College Board will be looking for exactly that as well. So, as I stated a number of times, we are still live streaming, and especially the time of this filming on Tuesday, there will be one tonight from 4 to 7 p.m. Pacific time, because these types of problems will be on there without a doubt, no matter which year of test practice that we have done so far. So again, you can email me at labcoatmath@gmail.com, or you can tune into that live stream where you can have your problems answered live, and we can definitely go over things like this without any other hesitation. So with that, this will be the conclusion to our lecture series on definite integrals, although we have some last few example problems to go over, and then from there we will get to our next series about areas between multiple functions. Doesn't that sound exciting? I hope to see you there.